Hey everybody, my name is Andrew. To kind of make a long story short, I have a background in astrophysics, but I was working in software when I was playing around with some math, and I kind of had this realization that Einstein made some assumptions that made more sense before the observations that gave us the Big Bang. So I started to play around with the math, realized I could do something with it, quit my job, became homeless. I'm living in public housing right now. Before that, I was homeless for like 4.5 years. Um, uh, yeah, the point I'm trying to make is that I really think I have something kind of significant here. So I'm going to try to walk everyone through this derivation that I found, and I really hope that this lands in front of the right person, somebody with an open mind that's willing to consider that this admittedly sort of abstract geometry might describe our universe, because it's what I'm going to propose here is it's the only possible um, solution to Einstein's additional this d equals vt gamma equivalence. It's the only solution to this equivalence that does not permit a single event to happen twice. If a single event is not allowed to happen twice, what I'm proposing here like has to be the solution. Yeah, so to justify that, um, to justify this geometry, I kind of use this thought experiment of a lighthouse on the clock tower, of an observer approaching that clock tower, and how that if both observers are using the same timekeeping device, that kind of produces some paradoxes that I believe are truly impossible. And from that, the only possible conclusion that allows for Einstein's additional factor of gamma, while both observers agree on the time that the observer reaches that time, that the timekeeping device, or any arbitrary point in space, assuming that is geometry. There's no reason to believe there's anything special about approaching a timekeeping device. But yeah, but I mean, so the only possible conclusion to draw is that the 2 points in space are further separated in the coordinate system of the observer who is in motion, which kind of aligns itself with the notion of cosmic inflation, which we can now make instead of time dependent, velocity dependent, or velocity and mass dependent, kind of as a function of like a cumulative velocity and mass, like a sort of like a vector field. But we can, we can from this geometry, I'm going to show you here that we can derive through a numerical intersection, a direct equation for magnetic divergence through electromagnetic parameters that gives gravitational acceleration. So to find that, all we do is take the derivative of gravitational acceleration with respect to radius. This gives ddrg, of course. If we consider that might be divergence, we should, assuming that this divergence, there's no reason to believe it wouldn't be radial. So assuming that it's radial, in three-dimensional space, that gives a cube, something to the power of three. So to find the inverse of that, take the cube root. So take the cube root of ddrg, and then that gives us this numerical intersection with the fine structure constant. And from this, if we basically swap this over, so isolate all the electromagnetic constants on one side, cube it to get rid of this root right here, and then swap the r over to this side, algebraically, of course, and then integrate r, that gives us the square root of the golden ratio times 10 to the 42nd, to what I feel is like undeniable accuracy that there's something here. But we can keep going, that this model does not end there. So if we consider that these components right here would be like the ds part of gamma, so gamma represents like some 1 plus ds, that this might be like that small ds part, that we should then consider that as being 1 plus that as being equivalent to gamma. And as you can see here, the intersection with our radius, is very tight. But getting back to what I was saying, if we consider that this is, 1 plus the same 4 components that we had earlier, 1 plus those 4 components gives us gamma, and then we solve Einstein's equation for gamma for V, substitute the values that we found in for that gamma, and we find a velocity that is close to our velocity relative to the CMB, but it's not. It's actually that velocity times 1 plus alpha. And I mean, it's like it seems like it would be a safer bet to say, oh, this it's an approximation for our velocity relative to the CMB. But I truly believe that with the consistency that this 1 plus alpha pops out of this relationship, especially the relationship between velocities, I really feel that there's a high probability that there is something there. Um, yeah, and then here, this is just me doing exactly the same thing with the gravitational parameters. And as you can see, originally you don't actually get our kinematic velocity. Originally we get our cosmological velocity, and then we have to integrate what I'm calling a time equivalent quantity, which is just it's just like a ratio of not I don't want to call them velocities because that implies like time dependence, but a ratio of the magnitudes of motion really. So the magnitude of some vector divided by like that unit vector, integrated over like temporal progression. I don't want I really don't want to use the word time because that implies like a physical quantity, and we're removing that quantity as any like it's just a mathematical tool at this point. Yeah, so then if we integrate that, then we reach our kinematic velocity, which again follows that same pattern of our observed velocity relative to the CMB times 1 plus alpha, to a very similar degree of accuracy. Um, and then here, this is just me. I'll let you guys read this. This is me just kind of like exploring how this equation holds for other bodies in our system, and how it holds for that there's a pattern. That it's not just random. That there's for slowly moving, for slowly rotating more massive bodies, it trends towards alpha, and that um, for bodies, basically everything closer to the sun, like the smaller bodies in our system, that it tends to trend towards alpha times 2 minus alpha. And some theory as to why that might be the case, which it makes a lot of mathematical sense, but I'm still not able to derive a function, mathematical derivation for this function, like a Newtonian derivation for this function. But I'm very very confident that it's associated with rotation, and I'll show you where that's associated with rotation in just a second. Right here, where if we consider that the divergence of the magnetic field would not be equivalent, or not would not be zero, it would be equivalent to the divergence of the spatial system. So that would give del dot b is equal to alpha times 2 minus alpha cubed. And then if we consider that del dot e should be c times del dot e or del dot b, then that gives c times alpha cubed times 2 minus alpha cubed. But that doesn't give us our rotational velocity. If we apply this spinner, I don't want to call it a spinner. I hate using that word. It's associated with spin. I don't know what else to call it. This thing right here is some function of spin. I don't know. I don't know what the function for it is. But if we kind of consider the fact that our constants are most accurately measured here, we should find that this function holds most accurately here, and that if we apply that I'm not even going to use the word spinner because it's a misapplication of the word, and I don't want to do that. But but then if we do apply that, it arrives at our rotational velocity at the equator to within like 0.3 meters per second. So like within walking pace for a velocity. So if you can imagine walking around the equator in 24 hours, like walking at that pace compared to like a walking pace, like that's the ratio of how much we're off. Um, and then here, this is probably the best observational example of at least the most recent kind of astrophysical observational example of where this model intersects with recent research. And that's so if we solve, usually our standard orbital velocity, of course, it gets more complicated, but the Newtonian derivation is, this centripetal force equals force of gravity, and then you solve it, and you come up with like a standard equation for a standard or stable um, orbit velocity. But if we instead solve this trigonometrically using this model of divergence, we end up with this, which is obviously not, dt is obviously not equal to 1. It's slightly higher than 1. So if we, again, apply this as gamma, um, solve Einstein's traditional equation for gamma for v, substitute this back in, again we end up with the same velocity approaching that 1 plus alpha. And then where this really gets interesting is if we, instead of allowing that this, basically following the observer in motion in that coordinate system, if we instead were to like force this to be in the coordinate system of the observer who is at relative rest, by saying that dt is equal to 1, then we end up with this velocity equation, which ends up being a little bit higher than our standard orbital velocity equation. And if we see with recent research, it intersects almost perfectly with this observational work done by Anna Eilers, I believe his name was. I really hope I wrote her name down somewhere. Yeah, out of MIT. I really wish I can give better credit to her, but yeah, but out of her recent research work, not that recent, but her work, which gave them very minimal error margins, and as you can see, I mean our predicted velocity aligns with her work at precisely our sun, or just about precisely. I mean you can see it's off by a little bit, but I mean it's as close as one could expect. And then there was one other thing I wanted to touch on up here that I skipped over. Oh, this derivation right here, where if we consider like the radius independent kind of velocity of this, I'm not very confident that it's a velocity, but it gives units of velocity. So if we consider this magnitude rather, compared to the velocity of our orbital velocity, as you know, comparison of velocities would just make sense. We end up with this relationship right here, which again, I don't have a derivation for alpha. I don't know what it is, but I'm really hoping that now that we can study this on like a macroscopic scale, that somebody out there is going to be able to figure this out, because it pops up everywhere in this model. And I mean, with this consistency, it's like, I mean, like this model does require like a couple, like it's logically consistent all the way through, but it produces the geometry that it's so abstract that it takes like some like it's like, I mean, I consider, like I think of it as like the way like it took us so long to realize how big the universe was. It's also going to take us a while to wrap our head around this geometry that the geometry that we experience might not be very like representative of the actual geometry of space, and that because of this fourth axis, which is entirely induced by curvature. Yeah, so I guess I'm going to leave it there. I mean, if anyone has any questions, I mean, I've recorded this video about 10 times, so if anyone has any questions, just please get in contact with me any way you can. All right, thank you.